Hi, and welcome to the first lesson of Pre-Calculus 20. We're going to be looking at section 1.1, arithmetic sequences. If you are watching this on YouTube, you may want to look at the bottom right corner of the YouTube window, and there'll be a space that you can click on to maximize it so you can look at it on your whole screen. Okay, otherwise it can be pretty hard to read what's written here. So we'll just continue on. Arithmetic sequences is our first topic. So we'll begin by defining what a sequence is. Okay. Sequence is an ordered list of elements, and each of those elements is called the term. So it might be a list of numbers that are separated by a comma. Each of those numbers is called the term. Okay, and so put together we call that list a sequence. Okay. One thing about a sequence is that there's going to be a pattern or rule that can be used to determine the terms. Okay, so if you know what the pattern or rule is, you should be able to find any term in that sequence. Okay, so here's some examples. Okay, you can see that's an ordered list of terms or numbers separated by commas. So if we look at that, can you figure out what the rule is? How do we get from 4 to 7, and then from 7 to 10, and 10 to 13? Well, we're adding 3 to each number to get the next number. Okay? All right, so we should be able to continue on with some more terms, right? If we add 3 to 29, we'd get 22, and then 25, 28, etc. Okay, so knowing what the rule is, we can continue with the sequence. All right, let's try another sequence. This is a different type. Okay, instead of adding here, we're going to be multiplying by 5. Okay, so if you look, it works for every term. There's got to be that rule. Okay, so 5 times 5 is 25. 25 times 5 is 125. Did I make a 3? That's a 5. Okay. So to continue on with some more terms, we just multiply by 5. 3,125 would be the next term. And then 15,625. And then 78,125, etc. And you could keep going because you know the rule. Okay, next. This one's different. Okay, you get from 1 to 2, and then 2 to 4, and 4 to 7. Okay, you might want to look at whether you're adding or multiplying. Okay, so maybe just to start, we'll say, well, here we added 1, and here we added 2, and here we added 3, and just do what you need to do to look for a pattern. Okay, so you can see that you're always increasing the number that you're adding it by, or that you're adding to it by 1. Okay, so it looks like to get the next term, we're going to want to add 6 to 16. Okay, and then I think we're going to want to add 7, and then we're going to want to add 8. Okay, so that's a little bit of a different one. Okay, the next one's kind of like that, although if you look at what we're adding, we add 1, we add 1, we add 4. Okay, which kind of tells us that if we add 1 and then 1 and then 4, we probably don't have a pattern. Right? So maybe look at what's being multiplied. Okay? We're multiplying by 1, and then we multiply by 2, and then we multiply by 3, and then by 4, and then by 5. So you can see that that appears to be the pattern. Okay, so if we multiply 120 by 6, which would be the next thing, we get 720. You multiply that by 7, 5,040. Multiply that by 8, 40,320, etc. Okay? So those are sequences. Now our topic today is arithmetic sequences. Okay, so there's a specific rule for that, and that is that you're always adding a constant term to the previous term. So if you look at the sequences that we have 2 that involve adding. Okay, this one and this one. Okay, but only our first one involved adding a constant term. We always added 3. That number didn't change. So that makes that an arithmetic sequence. Okay. So of the 4 sequences above, only the first one, 4, 7, 10, 13, 16, 19, is arithmetic. Now there are certain things, not very many things, that we use to describe a particular sequence. Okay. We use the following variables. We use t sub 1 to describe the first term. Okay. And so in this case, that would be 4. Okay. N would be the number of terms in the sequence, or the number for a particular term. Okay, and I'll get back to that in a second. D would be the common difference. So in this case, what number are we adding? And that number can be negative. So if you're subtracting, the common difference would be negative, but if you're adding, the common difference would be positive. So for this particular one, our common difference is 3. We're always adding 3. T sub n, that's the nth term of the sequence. So if you want to be able to express something for any term in the sequence, you can use T sub n. But if you wanted to look at, say, the third term, you might say that n would be equal to 3, and then T sub 3, okay, you would put instead of T sub n, and you'd say that's equal to 10. And you could do that for any term. Okay, here this is the fifth term, so if you wanted to say n would equal 5, then t to the fifth would equal 60. Okay, that would be the nth term if n equals 5. Okay, so in order to try to find a general formula that we could use to find any term, we'll look at how each term is related back to the first term. Okay, so the first term is 4. Okay, we can get the second term by taking the first term and just adding the common difference, right? So in this case, we get 7 by taking 4 and adding 3, right? The third term, you could say that you take the second term and add the common difference, or you could say you could take the first term and then you're adding the common difference twice, right? You get from the first term, okay? The fourth term, and one thing that's good about this is that if I want to know what the 20th term is, okay, if I wanted to say that, say the 20th term, well, that's going to be equal to the 19th term plus a common difference. Well, that's good to know, except that now if you only look at it that way, then you need to know the 19th term to know the 20th term. Okay, but wouldn't it be nice if we only needed to know the first term to know the 20th term? So if we just look at it where we're always relating things back to the first term, then we don't have to know so many terms. Okay, the fourth term, you would take, we would have to add one more common difference to the first term. Okay, and so looking for a pattern, remember we said that for the second term, this is n equals 2, okay, and we're multiplying by d one time. Okay, for the third term, so n equals 3, but we're multiplying by d 2 times. Okay? And when n equals 4, we're multiplying by d 3 times. So I think that we can safely say here that for every for any term, okay, we would take the first term, and then we would add how many factors of d? Well, not n, but 1 less than n. Okay, right? Because when you get to the fourth term here, you only needed to add, you only had to go up 3 steps, right? To get to the fifth term, you only had to go up 4 steps, right? So it's always, that's where we get the n minus 1 from. And this is really handy, this formula here. This is the important formula for arithmetic sequences. It's called the general formula, or the general term formula, or the arithmetic sequence term formula. And so that allows you, as long as you know what the first term is, and so as long as you know what the first term is, let's not underline the n. We'll say if you know the first term and the common difference, then for any value of n, that means a term for any position in the sequence, you can figure out what goes in that spot. Okay, so if I wanted to know the 100th term of this particular sequence, okay, I can just say, well, the 100th term, t sub 100, is going to equal the first term plus 100 minus 1 times d. And for this one, we know that the first term was 4, and then we're looking at 99 factors of 3 that we had to go up. Okay, so 99 times 3 is 297. Okay, so we know that the 100th term is going to be 301. That should be a plus sign right there. Okay, So yeah, it's a very useful formula, and we'll see in the examples that are coming up how to use it.